Hello, we are working on Unit 5 review that involves unit circle. So here we are. You can first work on the review, and if it seems confusing, then come back here, watch the video, or you can watch the video first and then go ahead and attempt the review. It is all multiple choice questions. Let us begin. The first one's asking me to convert degrees to radians. They've given me negative 188 degrees. And I know that to convert from degrees to radians, I have to multiply by pi over 180. And at this point, if you can see, all the answers are in decimals. So that's a clue that, hey, pick up the calculator, plug in negative 188 times by pi, and I recommend that you use the actual pi button on the calculator. Multiply that, divide your answer by 180, and one of your answers should match. Round it to 2 decimal places. All right, because all the answers were in decimal, so I knew they used calculator. This one right here, you can see that the answers are not in decimal. In fact, this tells me that the radicals were left just the way they were. So I have to find sine of 2 pi. I go back to the unit circle. 2 pi is the same as coming back after one revolution, being at 0 degrees or 0 radians. So this refers to 2 pi. Now the point here is 1 comma 0, and from my knowledge and also from the key given here, sine is the red one, which is the y-coordinate, so sine of 2 pi is 0. There we are, so it's this one, and if you plug it into calculator, you can plug it in the calculator, but keep in mind that your calculator is set to, because this is in radians, so your calculator needs to be in radians and not degrees. Number 3, use the properties of trig functions to find the exact value. Now, instead of using the properties, you can also go ahead and use a calculator because 50 degrees is not on unit circle. But when you do that, make sure your calculator is set to degrees. And you can do step by step. Like you can do tangent 50, find the answer to that. Then go ahead and find sine 50 over cosine 50. Find the answer to that. And then go ahead and subtract the two answers. That should get you the correct answer. Then comes in the next point. They've given me a point here, 4 nines, and then root 65 over 9. This is the x coordinate, obviously. This is the y coordinate. And they're just asking me to find sine of t. Now, sine of t can also be referred to as sine of theta. So if you want to change this to theta, if that makes you feel better, that is the same thing. Sine is the y coordinate, as we've discussed so many times. Y-coordinate refers to sine value and x-coordinate refers to cosine value. So all I have to do is look at the y value, and that gives me the sine of t. So sine of t is equivalent to root 65 over 9. That's it. It was that easy. We've done harder stuff than this in class. Find the exact value of sine of 0. Now that 0, you can call it 0 degrees or 0 radians, but basically 0 degrees, 0 radians is the same spot. The coordinate here is 1, 0. Sine is the y coordinate, the sine of 0, 0. And you can also use calculator for this. I mean, I know I say it says do not, but feel free to use it. Then comes in an object is traveling around in a circle with a radius of 10 meters. So radius is 10 meters. If in 15 seconds a central angle of 3 radians is made, time is 15 seconds. Central angle, so theta is 3 radians. The question is asking me what's the linear speed. Linear speed. That reminds me that we had two formulas. Angular speed is theta over t. Linear speed is radius times the angular velocity. So I cannot use the linear speed formula directly. I have to first find angular speed, so I can plug it in here. To find angular speed, I'm going to use the first formula. Is the theta given to me? Yes, it is. And you know what? Theta is actually given in radians, so I do not have to worry about converting it from radians to degrees. I'm going to use it the way it is. Time is given to be 15 seconds. So in 15 seconds, an angle of 3 radians is being formed. If I can simplify this, 3 goes into itself one time and 5, so 1/5 of a second. Now that I have angular velocity, I can take that and plug it in my linear velocity formula. Radius is conveniently 10. Angular velocity is 1/5. Do keep in mind radius is in meters and it was 5 seconds, so the units are automatically going to be meters per second. 1/5 of 10 we all know is 2 meters per second is the linear velocity. Moving on, this one's asking you to find cosine if you want to make it change into theta. They're just asking you to find cosine, and cosine is the x-coordinate, so boom, boom, there is the answer directly given to us, the x-coordinate. All right. Here's another one. This one's asking me to convert degrees to radians again. When I look at the answers, they're all in decimals, so that tells me that I can use a calculator. Negative 24, or you can just do 24 and stick a negative with the answer, times pi over 180. And again, I encourage you to use the actual pi button on the calculator rather than 3.14. Need to be rounded to 2 decimals. So once you grab calculator, once you plug this in, you should get the answer. This one's asking me choose the figure that gives me that angle. Like which of these angles, by the way, this got chopped off a little. Which of these angles refers to 3 pi over 4? The best thing is go to unit circle and see if you can find 3 pi over 4. 3 pi over 4 is right here. So they're referring to this angle. Right? 3 pi over 4 is basically 135. So they're actually referring to 135-degree angle. And you just have to match up which one is in, by the way, the second quadrant, third, and fourth. So the angle is in second quadrant. Let's see. This is in the third quadrant, so obviously out. This is in the fourth, obviously out. This picture got chopped off, but I can see that it's in the third quadrant, so most likely it's C. I can't see D, but just when you work on it and you see D, choice D, please notice that that angle should not be in the second quadrant. Most likely it's C. Moving on, convert this to degrees. This one is in degrees, minutes, and seconds format. So the answer is going to be 5 complete degrees and then some decimal value there. And you can see all 3 answers have point something. So the first job is to take 5 minutes, convert it to degrees by multiplying it by 1 over 60, get that decimal value. And 5 seconds need to be converted to degrees as well. Gotta multiply that by 1 over this, get the decimal value equivalent of those two. And both of these need to be, both of the answers here, this plus this, will give me the decimal equivalent here. That should match up one of the answers. Okay, minutes and then seconds. Find the area of the shaded region. Beautiful. They've given me formula. They've given me this circle. I can see radius is given to be 6 feet. And theta is given to be pi over 3. Guess what? This is in radians again. How do I know? Because I see that pi. So the formula, half r squared theta, half is half, r is 6 squared, and theta is pi over 3. You can put that over 1 if that makes you feel more aligned with the numerator denominator. 36 pi over 6, which is equal to 6 pi. Pick up your calculator. 6 times 3.14-ish. That should be 18 point something. All right, the best part here was that theta was in radians, so I didn't have to do any conversions. If it was in degrees, then I would have had to convert it first. The point on the unit circle that corresponds to theta equals pi over 4. By the way, a lot of these are Math Excel, your homework problems. So if you're watching this, it's going to help you out on homework as well, from 5.1, 2, and 3. Which point corresponds to pi over 4? Theta pi over 4. Go to pi over 4. The point that corresponds to pi over 4 is root 2 over 2, root 2 over 2, both positive. And both positive. That's what it looks like to me. Moving on, find the values of all 6 trig functions 1, 2, 3, 4, 5, and 6 given the point. And we've done it so many times. So here we go. Sine is the y. So sine theta or t is y. Cosine is x. Tangent should be y over x, so root 3 over 2 over negative half. That should be negative root 3. Cosecant theta, I'm going to flip this over. Secant, I'm going to flip over cosine. And cotangent, I'm going to flip over this. That's going to be negative 1 over root 3. Okay. All the others are good. This is good, 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 good. So let's match them up. The other two have to be fixed. And you can match them up actually. I'm gonna just help you rationalize it. Feel free to match it. 2 root 3, these two multiply to 3. Rationalize that. Negative root 3, these two multiply to 3. And now these two are also fixed, and you should be able to match these up. Alright, number 14, find the exact value of the expression sine 60 cosine 65. You can plug it in the calculator. Make sure that your calculator is set to degrees, and then you can convert each of these into decimal and then match up your answer. Or sine 60 cosine 45. Sine 60, oh boy. Okay, sine 60 is the y, so root 3 over 2. Cosine 45, so root 3 over 2, root 2 over 2. Root 3 over 2, root 2 over 2. Okay, so this is root 3 over 2 times, and this is root 2 over 2. That looks like root 6 over 4 to me. And beautiful matching. Find the exact value of secant 60 cotangent 30. If you go to the unit circle, none of these are on unit circle, by the way. So you'll have to first find cosine 60 from the unit circle, which is half. So secant 60 would be, flip that over, right? So this is 2. Then to find cotangent, I'll have to first find tangent of 30 from the unit circle, which is root 3 over 3. And then I will have to flip it over to get the cotangent, which is 3 over root 3. So 2 times 3 over root 3. This can be put over 1. That's 6 over root 3. But that's not acceptable. I'll have to rationalize it. And I noticed that 3 goes into it 2 times. So the most simplified answer is 2 root 3. It was a little tricky, yes. There were several steps involved. Secant, to get to secant, I had to first find cosine, then flip it. To get to cotangent, I had to first find tangent at the same angle though, flip it over, and when I flipped it and multiplied them, I ended up with this, and then this was not all the way done. I had to rationalize it. This one's saying, hey, both of these are given, and you have to find the other 4. Right, hopefully that should work out as well. So tangent is going to be y over x. Y here is the sine. 5 and 5 can cancel. So we have negative 1, 2 root 6. And the issue is rationalizing. Root 6 over 12. That's the tangent. So this goes with this. Alright. And then cosecant, for cosecant theta, I'm going to take sine value and flip it over. So that should be negative 5. For secant, I have to take cosine value, which is in the question, and then I have to flip this over. Then rationalize it. And then hopefully the last one should be this. Alright, we are on 17. This question, it's an expression, 3 times sine of 90 minus 2 times cosine of 80. First I need to find sine of 90, which on the unit circle is 1. Then I have to find cosine of 180, which on the unit circle is negative 1. So 3 times 1 is 3, minus 2 times this is negative 2. Anytime you see 2 negatives, that's basically positive. Number 18. This should be on unit circle. Sine of pi over 2 is actually just 1. But cotangent is not, so I have to first find tangent of pi over 2 from the unit circle. Tangent is undefined. So that means it's probably 1 over 0. The cotangent is 0 over 1, which is 0, right? 0 over 1 is 0, yeah. So 0 plus 1 is 1. One more time. How did I get tangent pi over 2? Tangent pi over 2, if you go up to unit circle, it's given 0, 1, and then undefined. So this is the tangent value, right? Cotangent is, the formula is x over y, so you can go 0 over 1, which is 0. That's how I got cotangent. Turned out to be 1. Is that it? Yep, that is it. Review is taken care of.